Alright, for number 3, I'm going to be deriving the sine half angle ID using a version with a cosine double angle ID. Alright, so first what we start off with is cosine 2x equals 1 minus 2 sine squared x. And then for this case, since it's we're trying to derive using sine half angle ID, x is going to be any angle cut in half. So it could be 100 and cut in half, and then it would be 50. Or it could be 90 and then it'll be turned into 45 since it's cut in half. So we just flip x equals theta cut in half. So an angle cut in half, now it'll be x. So once we flip, alright, there we go. So once we just plug that in for x, it'll be cosine 2 times theta over 2 equals 1 minus, 1 minus 2 sine squared theta over 2. Alright. So once we just simplify this, it just changes to theta by itself. So cosine theta equals 1 minus 2 sine squared theta over 2. Alright, and then all we have to do is rearrange it. So I'm going to move this over to the right hand side and this portion right here. Negative 2 sine squared theta over 2. I'm going to move that over to the left hand side. So we just minus cosine theta and then plus 2 sine squared theta over 2. And the 1 just stays there since we're not doing anything to it. Changing this to 2 sine squared theta over 2 equaling 1 minus cosine of theta. Now we're still not done yet since sine still has all this stuff on it. So the first thing we can do is get rid of the 2 in the front. So we just divide it by 2. Dividing both sides by 2. Giving us sine squared theta over 2 equaling 1 minus cosine theta all over 2. And the only other thing we have left is the square. So we can just square root both sides, giving us sine. Sine theta over 2 equaling 1 minus cosine theta over 2. Let me fix this. It's a little bit wacky. It looks a little bit better. So we have 1 minus cosine theta over 2, all of it square rooted. And then for the last bit, we have to put plus or minus because the output is depending on whatever angle you put in here. So it's depending on wherever it is on the unit circle, which makes it positive or negative, and then this. And here, I'll go ahead and write the explanations out to the side. So this, just simplify this piece. And this one, all we're doing, right here, all we're doing is just rearranging. So rearrange. And then here, dividing square rooting to get the square off the sine. And then here, it's basically just, we're all finished. Leaving us with sine theta over 2 equaling positive or negative square root of 1 minus cosine theta all over 2. And that's sine half angle derived using that version of cosine double NYD. That's it.